So now we're looking at worksheet 4, electron configuration, noble gas configuration practice problems. The front of this worksheet is just information you already know, so you're going to draw that off-ball chart that we've practiced in many worksheets before. It's asking you questions about energy levels, sublevels, things like an orbital can contain at most 2 electrons. Okay, so all this stuff should be in your notes somewhere to define the rules. Okay. And you're drawing the whole chart here, so 1 all the way forward. What I'm teaching you that's new, and what you're really going to dislike me for, is a shorter way to write electron configurations. You'll ask why I didn't teach you this earlier. It's because you need to understand where it comes from. So for taking the electron configuration, and they give you different examples, we'll start with sulfur. And if you remember from the last worksheet, I told you you can figure out from the periodic table where you're ending. So if I find sulfur, just right here, I know with sulfur, and I'm going to write the energy levels here for me. For sulfur, it's going to end with a 3p4. So I'm going to write 3p4. And I'm going to work backwards. So before 3p4, we're going to look at our off-ball chart, and I'm going to go ahead and write it so you can see what I'm doing. So our S's, our P's, our D's, and our F's. Okay, so remember you don't get this on a test, so you need to be able to write it. And I always write S, P, D, F. I remember silly people do fail. Now, if you look at 3p4, so we're ending with 3p, so we're working our way backwards. So before 3p was 3s, and if you remember off-ball, you have to fill the orbital entirely before you can move on to another. So it's going to be filled completely. S is 2. Before 3s is 2p. So that's 6. Before 2p is 2s. Just 2. And before 2s is 1s. So 1s2. And I can check. 2 plus 2 plus 6 plus 2 plus 4 is 16. What noble gas configuration is it's using the noble gases. So the noble gases are these last column right here. I'm just going to highlight them for our purposes. What you can do with the noble gases is they can be placeholders. And so how you do this is you look at the element you're looking at, sulfur, and I look at the last noble gas. So if this is 16, the last noble gas is the one that came before 16, which is 10, which would be neon. And what we do is we put neon in brackets. And then we write whatever's left over. So neon ends at 2p6. So what that means is neon took care of all of this information. So all I have to write is neon 3s2, 3p4. Okay. So neon represents 10 electrons. So 10 plus 2 plus 4 still gives me my 16. So noble gas configuration means you're doing electron configuration, but you're using noble gases. So if we do one of the other ones, if we do manganese, 25 electrons, it's going to end at 3d, 1, 2, 3, 4, 5. So 3d5, before 3d5. For 3D comes 4s, so 4s2, before 4s is 3p6, 3s2, 2p6, 2s2, and 1s2. So I'm just going fast, right? If I add all these up together, I get 25. How to do noble gas configuration is manganese is 25. The noble gas that came before it is argon. So I would put AR in brackets. AR ends at 3p6. So after 3p6 is 4s2, 3d5. And I can always check my answer. So 18 that argon represents. Okay, so 18. You don't write that. That's just making a note for myself. 18 plus 2 is 20. 20 plus 5 is 25. Now, this last column is quantum numbers of the last electron. So if we're looking at the last electron, if you don't remember, you can write out the last orbital, which was 3p4. So the last electron you drew would be a down arrow. So if we draw that out, energy level 3, p is a 1, it's in this space, which is a -1 space, and it's going down, so it's -1/2. If you don't remember how to do these, make sure you look at the prior videos to remind you. Okay, same thing here. This ends with a 3d5. So 3d5. 1, 2, 3, 4, 5. 3 energy level. 2 for D. The last electron's in the last column, so that's a that's a +2, and then have a 1/2 because it's an upward spin. I'm going to do one last one with you, and then you're on your own. So if we look at, let's look at a higher one, which is uranium. Okay, so uranium's in the F column. So it is ending, if you had to write it out, with 5F, 1, 2, 3, 4. But I've been nice to you, you don't have to write it out. You do need to do noble gas configuration. So U is 92. The last noble gas before 92 is Rn, which is 86. So I would write Rn in brackets. Now Rn ends at 6p6, and it represents 86 electrons. So what I would do is I would look at what's after 6p, okay, which is 7s. You could also look at the periodic table and look at your electrons. So after Rn right here, the next thing, 87, 88, is 7. So 7s2. Okay. And after 7s, because 86 plus 2 is just 88, we need to get to 92. If we look at our chart, so the two ways to do it, we can either look here, after 7s is 5f, or we could have looked here, after this section we go down here because it's 88, 89, and U is at 1, 2, 3, 4, so 5f4, and 86 plus 2 plus 4 gets us at 92. So there we go, and then you would do the quantum numbers for F. So 5f, 1, 2, 3, 4, 5, 6, 7 orbitals. Okay, and we use 4. 1, 2, 3, 4. So 5 for the energy level, 3 for F. It's in the middle position, which is 0, and then it's up, so 1/2. Okay, so do the rest on your own. This is also my last video for you, so I hope you're doing okay, and good luck with chemistry.